I think Dua is not joining.
Dua is, yeah, she messaged me that she was going to join. She has a class at university. So let's see. If she comes in at the end, we'll have her speak then. So why don't you start off now?
Okay, okay, fine. Um, Welcome to all of us. My name is Azam Rashid, and I am working as a neuro company AI as a technical and for as a program instructor and also as a chief AI engineer. For last 8 to 9 months, we and our team members made some tools and some models regarding Alzheimer and other things. And basically, the Sir Ahmed also told you that the purpose of the training is not a traditional training. The purpose is that we explore new things and we explore the such things in AI regarding the neuroimaging and model building, and also we conduct classes from latest state of the art AI like LLM and how to implement the LLM form over inference and how the LLM works on the imaging of narrow imaging. These all these stuffs are involved in such training. Now I move forward just for the overview of our program. Basically, we are dealing uh, Alzheimer, and the most of these our data sets are got from Alzheimer disease, and the ADNI is the basic source, and other sources OCs and also Pakistan. We also work on Pakistan, but at the moment we also develop some model on Alzheimer and get some specialized data from Alzheimer for ADNI and OC side. Now, basically, uh, we prepared a tool. These are the two also available in the market, but these tools are not to the customized nature like that. The CAT is also available in NetLab people's use, and FSL is a basic library for utilization of MRI and fMRI, and other two frameworks like fMRI Prep and Clinica. These are the most up-to-date frameworks which are using by different neuro imaging radiologists and researchers. But the plan is that we utilize all these tools from our customized tool and our customized like software which facilitates from the data pre-processing pipeline and also facilitate from the imaging view of the 3D image regarding the images in the format of DICOM, NIFTI and other DWI format. These are now we move forward that basically this is the pure hierarchy of data pre-processing. Um, the the idea is that we get data sets from the reliable source. We are utilizing the data set from ADNI because ADNI is most reliable source for Alzheimer. And sometimes the data is available in the format of DICOM, but the NIFTI is a standard format. But many machines like Philips and similar machines, MRI machines, provide the data in the format of DICOM because DICOM format is used for many machines, but the latest machines are providing in the format of NIFTI because all the pre-processing tasks and all the research works and the reports are compiled in the format of NIFTI.
Azam,
Now,
sorry, Azam, sorry to cut you. Just a couple of things.
yeah,
Rugged was accidentally removed from the call, so I got a notification. I don't know, maybe I clicked. I'm on my phone right now, so maybe or you maybe.
okay, okay,
Uh,
okay, okay. I think
so
so. Uh, I
kindly let her in because she just messaged me in the group. Number one.
uh,
Number two, do let me know when you share your screen because I can't see your screen over here.
okay, okay. It's I think so. You view my screen.
Yeah, now I can share. I can see your screen. and I will
Okay.
just ask Ragad to join in again. Okay. I think
Okay.
it's
Okay.
open. I think she's been trying, but it's not letting her because I think she was removed accidentally. So I'll tell her to join in again.
Okay.
Please move
Uh,
forward.
okay. I continued to the from data sets. Basically, we
Yes.
train our models from two reliable sources. First is ADNI and second is OSIS. The ADNI is more reliable source for Alzheimer disease because ADNI provides all type of data regarding DICOM format, regarding NIFTI format, and also the PET amyloid analysis are also available in the ADNI. The datasets are categorized in the format of ADNI 1, ADNI 2, ADNI 3, and ADNI 4. And the data is available from 2006 to the current year 2025. All the data, I think so, more than um, for 10,000 patients data are available in the site. I told you the patients, but all the patients have many MRIs and fMRI. If we concluded in the format of 2D images, I think so, it's millions of images are available it ADNI side. Now, these are the basic
Uh,
tools, data
Uh,
processing tool.
Azam, before you move forward, I'm just going to add my one point over here. So,
Yeah.
guys, keep in mind that once we came to Saudi Arabia and we started consulting with doctors over here, especially at King Faisal Special Hospital Center. So, Dr. Faisal Al the head of the neuroscience sector section department, he came up with a very important point. He said that it's a good model that we're making, and we're using all this data from it, ADNI and OISIS. But he said, keep in mind that he also wants us to train our model on local Saudi and Middle Eastern data, data belonging to Middle Eastern people, because he and other neurologists as well are of the view that the model can be fine-tuned to an even higher accuracy because they feel that the brain compositions of Saudis and Middle Eastern people is slightly different from the brain composition of people that this data is from ADNI and OISIS. So in the future, King Faisal Hospital is also going to be sharing their data with us, which is MRIs, fMRIs, SMRIs, and amyloid PET scan data as well. And then that is also going to be used to train a model. Azam, please move forward.
Uh, Now we move forward that there are basically the some tools available from the data processing, but these tools are not providing the pipeline for the pre-processing of the narrow images because the CAT is available, but some technical stuff and some other things are not customizable. Similarly, the FSL is also a basic library and initial library for the visualization and pre-processing of fMRIs and MRIs. And the two basic frameworks like fMRI Prep and Kiniga, these frameworks are developed recent 2 or 3 years before by the researchers of the European researchers belong to Italy and Germany, and these libraries are very up to the mark for the pre-processing of pipeline of narrow imaging. And the problem is that the libraries are available in the form of coding stuff and in the form of bash scripts and Python scripts, but we develop our software, and I show you in the forward um, that our software use all the libraries in the GUI format and enhance the users who are not well available for the programming stuff and some like the other utilization of bash scripts and such like stuff. Now, our built-in tool facilitates us, but the idea is that it facilitates us and also it provides a basic guideline how these pipelines are working. Uh, Now the lecture is conducting that how we plan such things in our training and our future lectures. Now this is the basically a idea and flow chart how we develop a pre-processing pipeline, pure Python approach. First of all, we have adding a OSIS raw data, raw format data is the fMRI and MRI data. Most of the machines are available, the data in the DICOM format. Now we convert to the NIFTI format because the fMRI and the other structure like bit structure facilitate the NIFTI format. And we also there is a lot of doctor and lot of researcher have a too much problem for convert such data. First of all, they convert the DICOM data to NIFTI and then convert bit structure because bit structure is basically state of the art structure which is utilized by the fMRI prep and clinica. And I also make some state of the art tool. You just give the input and output folder and click on the button, and all your data is convert DICOM to bit structure. Basic idea is that we provide you the state of the art data pre-processing pipeline. Either you convert the data in the form in bulk format, yeah, either you convert the data in the single MRI to the data pre-processing step. And now there
And
are
Azam,
basically,
Azam, this is going to be a one-click process, right? They just upload the
yeah, yeah,
files and they can do
yeah,
it
yeah,
as a
yeah, yeah.
batch as well, and then it
Okay,
gets the output.
yeah, yeah.
Okay, okay, thanks.
Because the DICOM format have too much DCR files, and all the DCR files based on the slides. But in case of NIFTI format, all the slides, all the slices are available in the NIFTI. Uh, so when we process, yeah, when we apply some pipeline, it is structural format like this format in the future slide. The coming slides, the all the things are clear up. Now there is basically we have three types of basically the MRIs. In other formats are also available, but these are the most common format. First format is structural MRI. Structural MRI is normal MRI, and it is available in the T-weighted format, T2 weighted format, and fair format. I think so. All the people who well aware from the neuroimaging, you know that what is the meaning of T-weighted and T2 weighted. And the second thing is fMRI. fMRI is the advanced format of MRIs because in the case of fMRI, the bolt structure and other tissue structures are also visible as compared to MRIs. And in case of brain, some structural things are not visible. Yeah, vision is not clear in the form of MRI. Now, in case of brain, the fMRI is more productive for the diagnosis of Alzheimer and other things. And the other thing is PET processing. PET processing is other format. In this such case, a radiographic biomarker is injected in the blood. It's just like a test, but test is too much costly to the in case rather than the MRI and fMRI. Now we move
Azam,
forward. Yeah. Uh, uh, are you hearing me? Uh, hello. My voice is coming.
Yes, we can hear you.
Yeah, yeah, okay, fine. I think so, sir. Ahmed, something problem in the side. Now the slides. Now we move forward because this structure, basic structure. In case of structural MRI, we apply different type of reprocessing.
Azam, I'm just going behind. So everyone, basically what happens is, and I'll tell you a little bit how this Alzheimer's. Sorry, can you guys hear me?
Yeah, yeah.
Okay, okay, perfect. So sorry about my internet connection. So what happens is once they screen that, now a simple MRI costs about 700, 800 riyals at King Faisal Specialist Hospital. Once they see that the MRI is clear from that perspective, then they test for Alzheimer's. The Alzheimer's test is an amyloid PET exam. So that test is costing about 12,500 riyals at the moment, and I think there's only a couple of institutions in Saudi Arabia that are doing it. And like Azam said, that involves it's invasive. It involves injecting a radioactive tracer in your bloodstream, and then that tracer goes to your brain, and then they scan it. So it's a long process. So our final mission with our system is to just use one MRI or fMRI and give the diagnosis and save the patient from going through all that hassle and spending that much time and money and effort. Back to you, Azam.
Uh, Now the first process of pre-processing is a skull stripping because when we take imaging of the brain, the skull is also available in the brain side. Now there is a process, there is a some techniques like the templating and distillation, which remove the skull stripping, and other is tissue segmentation and the normalization like the bias correction and other thing like the data augmentation. The all processes are the pre-processing pipeline, and our software provides you all the things in one go step. I'll demonstrate in the next few minutes how the process take place. Now the other thing is fMRI, because the fMRI involves the slice timing correction, because the time factor and motion correction is also available in the fMRI. These are also reprocessing in the in case of fMRI, and the pred processing is also some normalization and code registration feature process are available. And at the end, we extract the features which are needed from the model training, because all the data pre-processing is done from two purposes. The first purpose is that if we train a model, first of all, we get a pre-processed data. We given to the model in case of transformer, in case of CNN, because we are building a model in CNN and use transfer learning approaches, and now move to the transformer like encoder and decoders. And also we apply explanation MRI, explanation AI, which is utilize all the things explain that the black box of all your image slices, how the tissues and how the which the area is affected by Alzheimer. Similarly, the other thing is that for researcher point of view, like the people who research on the Alzheimer and other brain diseases, we also need that. First of all, the pre-processing pipeline is also in such case, and after applying the data pre-processing pipeline, we they analysis the MRI for different perspectives like the brain structuring, brain tissue, and other cognitive tests are applied for such data. Now, basically, this is the library NI NIP NI means narrow imaging in Python. This is basically the library which embed all the libraries in in one go. And I am using such library. Another library is also available like NI Bible, Narrow Imaging Bible. But this library is too much good because all the libraries like SM, SPM, FSL, Free Server, and other plugins are also available in such library. I am demonstrating you such thing that because many people are moving from different type of libraries, and because uh, you people are not a professional programmer, someone body program like some routines, and the idea of the training is that you know that all the things, but all the things are done in a GUI format, uh, and you do not code that, you do not prepare a batch scripts for repeat processing of data. The buttons are available and all the things are processed, and the timeline is available in the front end, and all the process done, your data is prepared for the analysis purpose. This is basically the idea for the how we prepare the pipeline in the format of GUI, and the backend, all the libraries are processed. Now we move forward that how the NI.
Sorry, Azam, I'm just to make a point over here quickly, 20 seconds. So that's the discussion I had with Dr. Ashwag as well, and you're very right. That's the same issue we were getting in our last training program during the summer as well, because a lot of students were coming in who did not have a programming background, and obviously we want them to save time. And instead of teaching them programming from a scratch start, we give them all these tools under one window, under one house. So it's a one-stop solution that they can access all of this without having the need to learn programming and use all the buttons in the GUI. So the GUI, the final GUI, is also going to be a very simple and easy to use interface. And back to you, Azam. Thank you.
Uh, this is basically the pipeline processing pipeline high structure diagram. You have a data, a raw data, either you get the ADNI, either you get the hospitals, and there are a lot of subjects, and all the subjects uh, are applying the same technique. Like if you use the fMRI, the motion corrections are applied on that. You see that we utilize best of the tools for best of the working of pre-processing pipeline, because all the libraries are best for some purposes, because this is the all the things are got from the researchers and the results. You see that the we in this case there are four libraries utilized. First, the motion correction is done by SPM. The SPM is a MATLAB library tool, and it's also available library in the Python format. And the other thing is co-registration. Co-registration means when we apply a skull stripping and apply a template on that, we use a free server. Free server is also a library which is betterly perform the templating. And the other library is ARNT. ARNT means the or advanced normalization library. It's abbreviated for ARTS. Basically, the word is advanced normalization technique structure. And in such case, the ART is very useful for the normalization process, because the normalization is basically the too much good results in case of ART. And similarly, the FSL is also using for skull stripping, but the smoothing function is also better performed by FSL. It depends. We utilize all the things in our software. You use according to your need and according to your results how you perform that. Now, similarly, we move forward that how the libraries are used. That if you use NIV library, you see that different interfaces. Interfaces mean just like packages. These involve all the libraries, and you see that for motion correction, we use the motion SPM library, and the code distribution we use C server. This is basically coding stuff. This coding stuff is just your information how the things are doing in the backend. But in our case, you do not need to perform some like programming like stuff and other things. All the things are doing in the backend. You just give the contents parameters, and all the things are done. Now, basically, I move forward to the practical side, how the things are do that. Wait a minute. This is basically over. I go through the GUI. Now, I after the GUI, I show the practical. This is basically our tool, the MRI pre-processing pipeline tool. This is basically a first version. We apply some other things and other facilitation regarding the fMRI prep bulk pipeline. All things are also embedded in future in the recently it supply a MRI and fMRI pre-processing in a single go and some subjects, but in the bulk format, we also make some other utilization of library like FMR Prep and Clinica. Now you see that this is basic interface of our MRI.
Azam, I'm just going to quickly add something over here. So, guys,
Yeah,
also do keep in mind, everyone, that this MRI pre-processing pipeline is different from the NCAI final product that we're making. So the NCAI final product is basically a doctor goes and uploads an MRI or fMRI, and the system does everything. It does the pre-processing stuff. It does the stuff with the LLMs and the AI. and runs it through a model and then generates a report via explanation AI. I think I've shared a sample report, our first report in the group as well. So that is an automatic system that it's a one-click stop shop. It does everything, right? But for the purposes of this class and to help Dr. Schwag and her students especially, and for training purposes, this is a second model that we've made. And also doctors can utilize it. Obviously, it's going to help them as well. And this is the solution that is for the pre-processing stuff. And so that a person can go in and they can use these different tools and they can generate different results out of it and look at images different ways and apply all these steps. So don't get confused between the two. That other main product is different from this one. This one is primarily made for Dr. Schwag and the students and other people as well to help you guys out. Back to you, Azam. Thank you.
Okay, now move to second screen. In second screen, we give a uh, information guide. Either we use the structural MRI and either we use the functional MRI. We demonstrate live in few minutes. Now we present you in the slides because the slides are still and all the things are visible now. Uh, Now we select in the format of either we select the NIFTI format, either we select the DICOM format, and after selection that we provide a path of your file. After giving the path, the next step is that the pipeline giving you first of all the pipeline require you how which process you just need you check mark such process, and after check mark that the all the processes are in block format, and after that locking the format. This is basically second rule. Now I move forward to the practical demonstration because the things are more vigilant in practical way. uh, I wait a minute. Over. Now we move forward. That just wait. Okay. Now I am starting such tool. The tool is basically in the format of Streamlit. Streamlit is a library which is utilizing that for the pre-processing for the production purposes. Uh, but in the production case, we also built our GUI in the Next and React framework. But as the Streamlit is also a, framework which is GUI also very popular for the purposes of development and some other experimental. Now GUI are built in the Streamlit format. You give this that I'm giving some name of the experiment just like NCAI -02, and the experiment name I think the Alzheimer, and just note early detection give you the
Guys,
things.
just to reiterate, I know some of you who came to our last week's session might think this is a bit of a repetition, but this is by design, not by default, because we want to get you guys to get used to this tool. And so after you go through a demo today, then I will have a discussion with Azam and see how the progress is on the GUI, so that in the coming future, we get you to work yourself on the front end with the UI so that you can start practicing with your own data. So we will see what the timeline Azam has in mind for that at the end of the call. But I want you guys to get used to it. Don't get worried by the programming stuff that Azam is showing you. He's only showing that to you to show you what's going on at the back end, because we can't just give you a user interface where you go and upload something and then do a few clicks and you get everything like magic. You also need to know what's happening at the back end. So you won't be required to do any programming stuff at the back end. So that's a plus sign, but you still need to know what the processes are. So back to you, Azam.
Um, After the class, I am sharing you my email address. The people who are interested from the some little bit programming stuff, he give me email and their idea. I am also designing for such students like tasks, like pre-processing tasks, and how to build a little bit of models, and also building for the LLMs, how we build LLMs and how we interact the LLMs from our model. These all things are our plan, but the people who are interested in such like stuff, I also design this similar task and similar short projects for her, for them to utilize them. Now we move forward that you see that there are different type of stuff like structural MRI, fMRI, and DTI. This is a very format for MRI, fMRI, and structural MRI. Basically, the most common is structural MRI. I'm using structural MRI, and in structural MRI, you see that there are different format. NIFTI is a basic format, and this is utilized for many structures. Bit structure is also built on NIFTI format. DICOM format is an older format, and RRD is also a format. All the formats supported in our tool. We use NIFTI format, and after we basic path where the file is available. In our case, we have a NIFTI file in. Uh, you see that I have a test run file. Now we move forward. After clicking that, this is basically the things which he enhanced according to our requirement. You see that some basic necessity features are already checkmarked, like image conversion. If your image is in the format of DICOM, the tool is automatically convert in the NIFTI format. Image loading, image saving, image visualization, and the bias field correction. These are the basic uh, need of the pre-processing. Denoising is also the basic thing, quality control, normalization, and we also apply the skull stripping, slice timing, and other thing that. Now we move forward that we now in the next step. This is basically the steps which are designed from as a professional way and as a way which we customize that in future for our need. Basically, we utilize the best library in case of bias correction. You see that I am using two libraries, SK Learn and Lab GM. This is basically library. When we click on a library by default, I am selecting and enable the Lab GM library. And you see that after enable, the method is already enabled, and basically this method is uh, more for graphic card GPUIs. And you see that different parameters are also available, and you change every parameter. Similarly, that if we select at enable such library like STKLearn, it's also available all the parameter, and these parameters are enhancing according to our experiments and according to our need, because previously tell you that this is basically a first version of our pre-processing tool according to the need of the doctors and the hospitals who are not well aware about the programming. And we included also the bulk processing things like fMRI prep pipeline, clinical pipeline, conversion of structure. All the things are tabs are also available in such tool because this is the first version. And after you see that, I am applying the Langstrip method, and after that you see we have a diagnose denoising, and we use denoising for different libraries. Gaussian, NLM, TV, bilateral. You use any library, and the parameters are also available. You set your parameter, after that you set as value 6, because these things are also regarding the stuff of the programming. And the people who are interesting and who use such things according to your experiment, you change such value, and the things are according to your need. You see that different things are available that. And after that I am using the Gaussian. And after that, similarly, we have a registration purpose. Basically, we use all the best library. SPM is also available. FSL is also available. When we utilize the FSL, you see that all the parameters and all the things are available in the format. And if we apply such like SKIT, you see that all the things are already available in the format. Similarly, the SPM and similarly the IT key, all the things are available in registration process. Now we move forward that last thing. After you see that you select your configuration according to your need, you save the configurations and the configurations are locked in the format. You see that all the configuration you set that is a lock and or processing is uh, apply all the things, the pre-processing task. The task is in the ready format. Now we just click on the start pipeline button and you see that after we clicking the start terminal, the first process is our bias field correction is applying that, and after taking 30 to 40 seconds, the process is all the pre-processing process is done, and the visualization of the process is available in the front end side. And we also um, explore some other libraries and other things which are also embedded in such tool, because I think that it's a output and also the feedback of the peoples, which things are more involved and more useful for the narrow imaging. These things are also embedded in the that, and you see that in the back end, the also the process is running that. You see that the process is done, and when we move forward, the all the process is done. You see that in the terminal output, all the things are available and all the processes are successfully done. In case of some error and in case of some other thing, all the things are available in the format of GUI. And after that, you see that this is basically the structuring or image of all the process. These images are also refined, and also some other also features are applying on such tool. This is basically the idea.
Azam, sorry, I have some feedback over here. Just a quick point. So when you make the G, I know you're making it, but once you finalize it, the front end, the user interface, the GUI,
Yeah,
I think one suggestion that I have over here is that, like the sequence of images that just appeared after the pre-processing, a specific pre-processing step had been done. And I know we discussed this earlier, you and me, but I want to have the discussion here really quickly for everyone's benefit. Ideally, we should also have the option that as soon as the mouse hovers above the image,
yeah, yeah, yeah.
it should
I applying on the
magnify.
these images are magnify, and these images are also I am also doing that the after applying every spotlight image, the image is hover and image is in the format of just like the imaging tool, the zooming and de-zooming and other things are applied
Okay,
on that. Now
great.
I am,
Thank you.
you see that in the back end, and I also facilitate the experiment, all the information of the experiment, research experiment is available in the file format. This format is also in a downloadable form, and we apply a button. Uh, we facilitate the doctor how the things in the experiment he apply on the things and how the values, which values are giving you the result. These all things are available in the format, and these all JSON format file is downloadable in the final version of the tool. Now I am move forward the other thing that which is over the other thing is that how we convert this. Basically this is also a difficult process for doctor how to convert the DICOM format. We also embedded the button on the side, but basically the how these things are performed. Basically, this is a just like a, 10 to 15 lines code. We perform all the tasks, convert the DICOM format to the NIFTI format. I run the such program. Wait a minute.
Okay, while Azam runs the search program, I'm just going to quickly add something here. So the update is that I will be going to see Dr. Schwag at King Saud University in this upcoming week. I'm just still waiting to hear back from her for us for so that she can set the time with the dean. What's happening is since we are now commercially registered, we are pursuing a MOU with King Saud University. So me and Manal just messaged in the group. So we went and saw Dr. Schwag. That was our first meeting back in, I think, April, I think it was. And then that's where these ideas started flowing that we make this pre-processing tool that is going to help the students and it's going to help Dr. Schwag. And then we try and set up a neuroimaging lab at KSU. So that is all of that is now materializing. So since we've got the commercial registration now, I'm going to go and see the dean, and then we are offering to set up a neuroimaging lab at KSU. So our NCAI will be financing the setup of the lab. It's only going to be 2 weeks, two workstations to start off with, but I think it's a good start. It's going to help the students. They can work remotely via those machines. So that is the one of the main purposes of my trip. One was going to see the deputy minister at MCIT and the meeting at RDIA. Obviously, the collaboration with King Faisal Specialist Hospital and Research Center, and this KSU thing with Dr. Ishwag. So once I go and see her next week, and hopefully we talk to the dean, then we move things forward. And in the next, I say 30 to 45 days, we sign a MOU. I order the machines. We set up the lab over there. Meanwhile, Azam keeps working on the GUI and hopefully, inshallah, finalizes that so that by the time the lab is set up, we can actually get you guys to start working and using this pre-processing tool. So, excuse me, I've just given you a quick overview of what the steps look like so that you have a timeline in mind. And I think the timeline is that we should get you to get the lab set up and get you to start using this tool within the next 45 to 60 days. So 1.5 to 2 months. Hopefully, I'll try and reduce that time to 1 month, but a lot of it also depends on KSU because the signing of the MOU is also involves administrative process, and these processes at universities in Saudi Arabia can be sometimes slow. So hopefully, Dr. Schwag, I know she's working hard to push this through quickly, and so are we. So inshallah, we will reduce the timeline. Azam, from a timeline perspective, does that look feasible to you to get the UI set up?
Yeah, I think so. It takes approximately 30 to 45 days. The lab and all the things are finalized in the Dr. Shock site, and also the all the tools are available in the web format from the user perspective. Now we move
Perfect.
forward that now the conversion, we apply a button also in the backend how the things are do that. Uh, Basically, the DICOM files are available in the bulk format. You see that this is basically a DICOM of one patient DICOM file for MRI. And in DICOM case, you give the folder, yeah, directory to the tool, and the tool convert all the directory to the output in the format of the NIFTI. Basically, this is the conversion of DICOM to NIFTI. Now you see that we have a different DICOM folders, and these things are also available in the case in our tool in the GUI format. You first of all you give similarly that in the last tool you give the path of your DICOM file, and the output of the all the file on Nifty are also available. The output directory which is also available in the GUI format. Now we apply that. You see that we have the Nifty format is no the file, but after conversion the Nifty file is prepared. Now we apply such technique. You see that the conversion is process is it takes hardly 2 or 3 seconds, and to see that the all file is convert in the Nifty format. This is the format ni.gz. Gz basically compress the Nifty format for the processing and other point of view. The all the file Nifty files are available in two formats like .nii and .nii.gz. GZ means this is the format of the Nifty file, and we applied. And you see that we are not showing the Nifty file right now. I am just demonstrate in the coding area. You see that the header of the Nifty file is that the file is belong 320 to 20 at 25 pixelized, and the header provide you all the information which are available in the Nifty. Now the other tool is available. This is also a neurocognitive tool. Basically, this is a view tool in which you view any Nifty file, any DICOM file, and we just explore that the file which are making that. We explore the file in our tool. You see that the Nifty file is that. This is Nifty file which converting after the DICOM format, and I view that in our tool. And you see that because the format is not better, because I am choosing the random file, and the slices are not better in format. We utilize some other Nifty file. Uh, we have also available lot of files, and we apply that. We in MRA example, we have a Nifty file. We use such Nifty file, and you see that this is the best pre-processed Nifty file. We also pre-process for our last tool, and after you see that there is different angles of the you visualize the 3D tool. You see that this is the Excel view. You also move from your slice level, and it provide you all the slices of uh, available in the in case of such Nifty file. There are 182 slices, and you move forward every slice. The other thing is that the other locations and other upper and also available in the thumbnails. And after that, we have also apply a color mapping criteria. We apply just like that in Pinot, and you see that the coloring of the MRI is slices change. We also apply a plasma. We also apply a magma. These all are the coloring shades, and we have also the NI available. The different type of templates which are using from the pre-processing, like the skull stripping, and after that we apply registration. The MNII is the basic standard for templating. We apply a template of that template on that. You see that after applying the template, you see that the all the structure of the exchange, and after that we apply a we removing a skulls of the MRI, and the also available at that. And after that, we rotate such thing. We also make some other features like the GUI, like the hover and the zooming and other things that in the future version all the things are available. This is a over customized tool, and these tools are also available on the publishing side. You can view different type of fMRIs and MRIs in our tools.
Uh, Azam, thank you very much. I think this is you saved the best part for the last. I really like this feature of the tool. I think we're going to finish the lecture here because we're running after more than 50 minutes now. I think that's the ideal for attention span. I think anywhere between 45 to 55 minutes is a good timing for the session duration.
Yeah,
Also, I have to now rush to the Kaaba because I'm going to miss my Maghrib namaz. So let's finish this for today, and we will pick this up next week, inshallah. And
inshallah.
for everyone on the call right now, I'd like you to do one thing. So I like you to, I think most of the people we have in our WhatsApp group, for the people who are not in the WhatsApp group, they can email us. So ideally, what I want everyone to do is to send at least one question that they have in mind. Ideally, they can do it in the WhatsApp group so that the answers can be used for everyone's benefit and everyone can know. Number one. Number two, as Azam mentioned, for those of you, I know some of you have already emailed me, but for those of you who are interested in programming tasks and working more on the technical side, Azam, I'd like you to come up with a task for them. You can
Yeah,
share the task. You can share the task in the WhatsApp group as well, and then I can email everyone too to see who is interested, and that way we can set up a, like a discussion channel. I know you can do individual emails as well, but what happens is then the group doesn't benefit from over there. I think the easiest
yeah.
way to catch everyone is WhatsApp. So everyone just send in one question. I don't care how simple it is or how complicated it is. I want everyone to benefit from each other's questions and answers. And Azam will obviously answer all those questions, and wherever I can help as well, I'll obviously contribute. And then Azam, if you can please take a few days, take 3 or 4 days and work on a programming task, which is going to benefit the students, and also it can benefit this pre-processing pipeline they're building, or our main product, or from a neuroscience and AI perspective. It should be something that is doable by everyone who is attending. So,
Uh, One thing is that, Sir Ahmed,
yeah,
the person who are interested from the programming and such like stuff, who share me that my email, their CV or resume, their expertise,
okay,
then it's more feasible for me for making
perfect.
a task
Okay.
for your.
Okay, makes sense, makes sense. So anyone who's interested in from the programming perspective, please send in your resumes and your background information to Azam directly on his email, and then he will assign you a task accordingly. I think that's better.
I think your you are going to the prayer, and also the car is waiting for you. I think that
Yep,
it's
yep.
good session, and inshallah in next week the more things are explored. I think
Inshallah, inshallah,
okay.
inshallah. Next week. Okay, thank you, everyone. And Azam will be uploading the link for the session as well. So the YouTube recording goes up tonight. And inshallah, you can view that again. And for those of you who missed it, you can view it too. And inshallah, we will see you next week. Thank you for everyone for attending. Thank
Okay,
you. Bye bye.
okay, okay, okay. Allah Hafiz.
Good Hafiz. Bye bye.